Up, up, down, down, left, right, BA. Lately, we've been adding code that lets us view connected Wayland clients, but we really didn't have a way to control them. Today, that starts to change. There are 3 input types that the core Wayland protocol supports. There's keyboards, pointers, also known as mice, and touch. In this video, we're going to implement the keyboard protocols. Next time, we'll take care of pointers, but as for touch, we're just going to postpone that one for a bit. All 3 of these input types are created from the same Wayland seat global. A seat can be thought of as the physical seat at your computer desk. I'm going to go out on a limb here and assume that you have at least one mouse and keyboard in front of you, but you might even have more than one, especially if you're on a laptop with peripherals. They all belong to the exact same seat. If you've been following this project for a while now, you might be thinking, hey, didn't you already set up seats? Yep, totally did. These new seats are a bit different though. Same idea, but rather than filling the gap between Linux and the compositor, these new Wayland seats fill the gap between the compositor and the client. Our new seats are actually driven by our old seats, just relaying events through them. Almost like seatception, but way less cool. So I want my Wayland client to receive keyboard events, but how do I even know if the user has a keyboard available? Before the test client is able to bind to the keyboard APIs, we need to know what capabilities the seat actually has. If only there was some Wayland API that would allow the compositor to give us a list of these capabilities. Oh, well then, I guess all we need to do is figure out how the compositor is going to know which devices are plugged in and what they can do. When we set up the original seats in our compositor, one of the things we configured was libinput, which is a library that sends us events whenever some input-related thing happens. And it just so happens that when a user hot plugs an input device, that generates an event for us to consume. Using a simple logic check on the event, we can identify whether a device was plugged in or unplugged, and whether that device supports keyboard and or pointer input. Cool, that seems like a good anchor point for us to build from. Taking a closer look at the Wayland spec, a seat has a given capability if one or more devices support it. In other words, if the user unplugs a keyboard, as long as they still have a different keyboard plugged in, then their capabilities haven't actually changed yet. I think a good way to track this is by counting the number of devices that provide keyboard input. Whenever a libinput event fires for plugging in a keyboard-capable device, we just increment the counter. And similarly, whenever a keyboard-capable device is unplugged, we decrement it. If we give this a quick test, printing out our current device counts for each input type, we get some pretty large numbers. Okay, what if I unplug my keyboard, then plug it back in? That's interesting. Even a simple keyboard registers as multiple devices. And the USB dongle that I use for my mouse? Yeah, apparently that's considered several keyboards and mice as well. And even if I unplug everything, I still show having 4 keyboards plugged in. What? A few Google searches later, I learned this is fine. Everything is fine. The short, oversimplified version is that devices generally lie, but they usually have a good reason for doing so. Pretty much anything that has a button you can press is considered a keyboard. And yes, this even includes your computer's power button. I could improve our logic for determining what's considered a keyboard by looking a bit closer at the device's metadata, but I really don't feel a need to right now, to be honest. As long as our logic doesn't omit actual keyboards, then it gets my thumbs up for now. So now that we know what capabilities the seat has, let's go ahead and send the Wayland event to notify the client. It should be sent when the client first binds to the Wayland seat global, which is what we have here. It should also be sent whenever the list of capabilities changes, which is what we're doing here. Note that the second scenario doesn't mean send capabilities on every single hotplug event. It's only if a hotplug event removes the final keyboard or adds the first keyboard. The client doesn't actually care how many keyboards the user has in front of them, They only care if the user has at least one. When the client receives that capabilities event and sees that the seat has a keyboard attached, it then submits the get keyboard request to create a new Wayland keyboard object. When the user presses a key on the keyboard, the compositor will send that key data to our client through this object. But wait, if there are multiple Wayland clients running, they wouldn't all receive the same key events, would they? That'd be pretty terrible if you try to log into your bank's website and your definitely a calculator app also receive those same keystrokes. That's where keyboard focus comes into play. Only a single surface can hold the keyboard's focus at any given time, and that's the only surface that would receive the keyboard events from the compositor, with one or two exceptions. Sometimes clients like to render themselves a little differently based on whether or not they have focus, so the compositor shares this focus information with the clients through the keyboard's enter and leave events. My plan is to represent this by showing the focused surface with a solid white border, and all the other surfaces without a border. This isn't how we'll be doing it long term, but it's plenty good for testing our code. Now, here's the problem. Our test clients only make use of a single surface each, and in my infinitely bad wisdom, I'd made the compositor only track which client is front and center. But keyboard focus needs surface level granularity, not client level granularity. You know what that means? I ended up creating this window management utility file that tracks all of our surfaces. I use this to determine the rendering order now, along with which surface holds the main focus, and also some functionality for modifying this list of surfaces. Whenever things like the focus changes, it also emits the appropriate Wayland events. So this file centralizes all of our focus logic into one place, rather than having it spread out across a bunch of different files and functions. Its code still feels a bit messy to me, so I'm probably going to take a stab at cleaning it up at some point. But I'm waiting to get some of the other surface types implemented first, so I have a better understanding of what capabilities this file should actually have. I ran into a little bit of a pickle here. So I'd added the enter and leave events to this new file, but I noticed that my newly opened client was never actually receiving focus. So let's play a quick round of Spot the Logic Bug. So when I open a new client, it submits the requests needed to create its surface. When the surface is created in the compositor, the surface gains the keyboard's focus. This results in a leave event getting sent to the keyboard object associated with the previously focused surface, and an enter event getting sent to the keyboard object for the new surface. Then the new client creates its keyboard object. So, where's the issue? If you said the keyboard object doesn't exist when the enter event is sent, you win! I ran into this by accident, but apparently this is a totally valid situation that we should probably support, even though I didn't see it explicitly mentioned in the protocol. The fix I went for was to add some bonus logic to where our keyboard is created in the compositor. If the new keyboard belongs to the same client as the active surface, then I send an enter event from in here too. I think this is probably a good place to take a quick pause and look at a demo of what we've got so far. Keep an eye on the window borders. If I open the first window, it has the focus. If I open a second, the focus moves to the new window. The first no longer has a border. The same thing happens when I open a third. When I press Super Q to close the current window, the one with the focus goes away and the previous window regains that focus. Cool beans. Now for what we've all been waiting for. It's time for our compositor to send key press events. There are two relevant types of Wayland events for this: key and modifiers. The key event tells the client what key code was pressed or released, and is just a direct event forward from the compositor side. It gets sent whenever the compositor processes its own key event, and it's up to the client to properly interpret that key code using something like xkeyBcommon. The modifiers event is a bit different in that it's not a direct event forward from the compositor. It includes the current state of all the modifier keys, such as Control and Shift, and we only send it when a key press event causes a change in one of these modifiers. We also want to send this modifiers event immediately after we focus a new surface, so that the surface knows which modifiers are currently active without it having been the focused window when the key was originally pressed. I've gone ahead and added some stubs to the client-side handlers of these events. For now, they just print some of the data they receive. My plan is for us to use these events to let the user control the circle, which means I've also stopped updating the circle's position automatically when it's the focused window. The background windows still update though. If we run this quick, push a few keys, then quit out, and check the logs, we can see a few key press and release events coming through, as well as some modifiers events. Now let's make some use of these. These logs show that the keys being pressed are represented as numbers, but how can I tell if this number is a W or the up arrow? Sure, I could theoretically build a lookup table that converts a number to an identifier, but it gets a lot more complicated when you take into consideration the different keyboard layouts or custom key bindings, and even keyboard layers that the user can switch between. The same physical button on the keyboard is always going to send the same number in the event, but that number could translate to a variety of different things. And that's where XKB common comes in. XKB common tracks things like the modifier keys and the active layer, and it contains lookup maps for a lot of different layouts and languages. Once we get this set up on our client, then we can just feed it our key code, and it gives us a key sim that we can check against to determine whether or not the button the user pressed is, W or up. I already have the XKB common libraries installed on my computer since that's what the compositor is using. So all I needed to do here was add it as a dependency to the test client and then get it initialized. To do that, I create a context for it. I wait to get the key map data sent to us from the compositor, and then I initialize the map and the current state for the XKB context. Now in our key event handler, we can just shove the key code into XKB to look up the key sim and put that through a switch statement to determine which key it is. The client is keeping track of the press state for the four main directions, up, down, left, and right, as well as whether or not the shift key is being held. If I test this out, I can steer around the little circle with either W, A, S, D, or the arrow keys, and I can make it go faster by holding down Shift. I'm enjoying this far too much. Send help. There's one more thing worth mentioning. You know that modifiers event that I mentioned earlier? Yeah, so it turns out our particular client doesn't really need to make use of it right now. The key press for the shift key comes through on the key event perfectly fine, and that's good enough for our demo. The modifiers event seems to be arriving properly and contains the correct data, and we'll probably need it once we implement the ability to switch between active windows, but until then, I'm just going to kick the can on the client-side implementation and save a little bit of time. I came this close to putting pointers in this video too, so things like mice. But I decided that was probably too much content for this video, so you got that to look forward to next time. Speaking of, hope you enjoyed, and I'll see you there.